Okay, in our final lecture for Unit 3, we're going to talk about mafic volcanism. Remember, mafic, iron and magnesium, we should be associating that with the mantle, magma that is originating from the mantle. And so there are two different places where we might start to think about finding that magma that is coming from the mantle. First being those mantle plumes, those hot spots where magma is rising up through the mantle, leading to a volcano on the surface. That volcano will then move with the overriding plate, similar to that in Hawaii. Or we might look to a divergent plate boundary where the two plates are splitting apart in opposite directions, and magma can make its way up in between the plates. Both of these will produce mafic-rich magmas that then result in mafic-rich lavas and mafic-rich volcanoes. Okay, so now looking at this chart similar to the one we had before, we're now dealing with this lower category. Over here, we have very high temperatures and high density because of all that really heavy iron and magnesium. We have a relatively low silicon oxygen content, and because of that, we are now getting into the low viscosity. This is also produces low explosive eruptions. So in the last lecture, we were on the right here dealing with those high viscosity lavas. Now we're in the low viscosity lavas, low silicon and oxygen, high iron and magnesium, low gas content. It's not going to move as fast as water, but compared to the other types of lava, it's going to be moving very quickly. So low viscosity, low gas content, we're going to be forming volcanoes that flow out in all directions, lava that flows out in all directions, forming very, very wide volcanoes. They can still get very tall, but these things are going to be huge. The island of Hawaii is one massive volcano that stretches all the way from about 14,000 feet at its summit all the way down to the ocean floor. It is taller from summit to base than Mount Everest is tall. Some people don't realize that that is the largest edifice or largest structure on Earth, right there. These volcanoes tend to be very wide relative to their height because their lava is able to flow over great distances before cooling down. So we're going to talk about three different types of volcanoes that we can associate with this mafic volcanism, very high in iron and magnesium and basaltic lava compositions. So the first step is the fissure eruptions. These essentially occur along a plate boundary or a tectonic feature that has broken apart into a long chain. We will oftentimes get these walls of lava emerging out of these fissures. Again, those lavas flow very easily, and so they have nice eruptions that don't tend to be very explosive, but they tend to come out and spread out in all directions. Here's a nice little video sort of showing the nature of this lava, how it comes out and then moves into the downhill direction. This video is of a fissure eruption on the island of Iceland. Iceland is right on the boundary between the Europe and North American plates. And so it is right there on that boundary that is spreading apart in opposite directions. And so here we see the fissure eruption, see the lava coming out, and then it will flow downhill from the fissure. Pretty cool. Okay, next up are the shield volcanoes. These are the very, very large volcanoes that form through repeated eruptions of very fast flowing lava that spreads out in all directions. So these things tend to grow wide before they really start to grow upwards. And one of the most famous is Mauna Loa. This is on the big island of Hawaii. This is about 13,000 feet tall, and it has been growing over the last 700,000 years. Again, these eruptions usually occur along the sides when magma sort of breaks its way through a vent, and then the lava begins to move its way downhill. This sort of adds one more layer on top of the massive volcano that is Mauna Loa. And so this is a volcano that grows very slowly and incrementally through these much smaller eruptions. Here's just a look at just how large the island of Hawaii is. Remember, what we see above the sea level, above the ocean, is just the top of the overall volcano. Once we look underneath the water, the bathymetry actually reveals to us just how large this volcano really is and just how much lava needed to accumulate and build up in order for this volcano to come above the surface to form a volcanic island. Here's a nice video that sort of summarizes the way in which Hawaiians sort of react and respond to these less than violent, less than explosive eruptions. It sort of gives you a real understanding of comparing things like Mount St. Helens with something like this. It's pretty striking.
For the past couple of weeks, this river of red hot rock has been causing chaos in the streets of Hawaii.
I think it's faster than a turtle can move.
The lava doesn't move quickly, but nothing can stop it. And as you can see from this video, it destroys everything in its path. The lava is coming from Kilauea, a volcano on Hawaii's Big Island, which is home to these guys.
Aloha BTN, I'm Fiona.
Aloha BTN, my name is Sebastian.
I go to Volcano School of Arts and Sciences. It's about a maybe 4-minute car ride / bike ride to the national park, also to the crater. Right now, the lava is causing people to evacuate and causing homes to be damaged and pets to possibly be killed or they're running away. So it's not fun.
It's a slow-moving flow, but it's very hot, about 2,000 degrees, and it just burns everything in its path. But since it's slow-moving, people have time to evacuate, which is definitely helps.
Kilauea is one of the world's most active volcanoes. In fact, it's part of the reason Hawaii exists. It's what's known as a hotspot volcano. They form over places where molten rock or magma has built up under the Earth's crust. When enough pressure builds up, the magma comes out as a volcano. When it hits the water, it cools down and solidifies, forming new islands. While the hotspot always stays in the same place, the tectonic plates, which make up the Earth's crust, are constantly moving, slowly dragging the new islands away from the hotspot, which is why Hawaii's chain of islands looks like this. Kilauea has been erupting almost continuously since 1983, but this is the worst it's been in a long time. And there are worries as the lava drains out of the volcano, it could actually get more dangerous, because the molten rock will heat up the groundwater and create steam, which could cause the mountain to explode.
If we know the steam is coming and ash, we are ready to evacuate.
Sebastian and Fiona say it's a scary time for Hawaii locals, and they're really sad for their neighbors who have lost their homes. But it's also been amazing to see just how powerful nature can be.
I was actually filming some footage of the ash cloud. And
Okay. Loved hearing from Sebastian and Fiona. Yeah, last type of volcano is the cinder cone. This is sort of a tiny volcano just from a smaller magma chamber. Again, tends to form through smaller eruptions, moves vertically before laterally. Here are some examples of some cinder cones as well. These ones have higher or lower amounts of gas, and so these can actually be a little bit more explosive than the ones that we were looking at previously. And these can cause them to grow upwards because they tend to explode and sort of build up that way instead of flowing outwards. Sunset Crater in Arizona, just different examples of some cinder cones that formed about 1,000 years ago. Thanks, everyone. Do not forget to check out the lecture quiz for practice with all of these key terms, as well as your photojournal. See you all next week.